Okay, now we're going to go ahead and move into some examples using the exponent rules that I just showed in the last video screencast lecture. So we are on now to part 2, and we'll take a look at using those rules that we just saw in some examples. Alright, for example, typically your directions will say to simplify, and then they'll give you a couple of things to multiply here. Like m to the third power times m to the seventh power. Since we have the same base here, m, and we're multiplying and they have different exponents, the rule says that we're just going to add the exponents to give us m to the 3 plus 7, which is 10th power. Simple, simple, simple. Alright. Other examples similar to that, if we had a to the 0 power times a to the 4th power, we could think of that a couple of different ways. A to the 0 power is really the same thing as 1, or we could add the 0 and the 4, which still add to equal 4, and 1 times a to the 4th would equal a to the 4th. So there are really a couple of different ways to think about it. Either way that you choose to think about it will get you the same answer, a to the 4th. Okay. I'll go through a few more of those. If I had, for example, n to the 9th power times n to the negative 9th power, I would again add the exponents, but here 9 plus negative 9 is going to give me 0. This is not my answer. If you type this into Course Compass, you will get the problem wrong, because what Course Compass is wanting you to do is type 1, like that. Because remember, anything raised to the 0 power is equal to 1, except where n is equal to 0 itself. But typically, we just assume that the base is not 0. Okay. Just to kind of make sure we've got the idea here, if I had y to the 3rd power times y to the negative 7th power, that would equal 3 plus negative 7, which is going to be negative 4. But if your directions say to write using positive exponents, then remember we have to go back to that first concept we learned. That's going to be 1 over y to the positive 4 power. This here is typically, I think, what Course Compass is looking for. It may accept this on occasion. This one right here, I think, is typically what it's looking for, if it doesn't actually tell you what it's looking for. Alright. Moving along here, we'll take a look at a couple more. If I had 7 to the 3rd power times 7 to the negative 5th power times 7, I would use the same basic rule. I've got all the same bases right here, all 7s, and I'm going to add the exponents. The thing is, this exponent here on the end is really understood to be a 1. So on this 7 right here, the exponent is understood to be a 1. 3 plus negative 5 is going to be negative 2, and negative 2 plus the understood 1 is going to be negative 1. Making my answer for this problem 1 over 7 to that understood first power, or better known as 1/7. Okay. Other things that they are really going to want you guys to know how to do are problems like these, where you have really two monomials multiplied together. 2x to the 3rd times 3x to the 4th. In this situation, it's really just an extension of what we've done before. We're going to multiply the x's together and add their exponents and get x to the 7th power. But in front of it, we'll just multiply these numbers out in front of the variables together, 2 and 3, and get 6x to the 7th power, like that. Okay. So that's one thing to be on the lookout for. Right. These are probably mostly review. I'm sure many of us remember how to do these, others not so much, but either way, we'll just review it. Another thing that you might want to be alert or on the lookout for, we have negative 6b to the negative 4th power in parentheses. And we're going to multiply that by 2b to the negative 7th power. Okay. I'm sure that a lot of us remember this, but just be sure that you know that a negative 6 times a positive 2, or a negative times a positive anytime, is going to equal a negative. Okay, so negative 6 times 2 will give me negative 12. Then, with the b's, I just add their exponents. Negative 4 plus negative 7, and that's going to give me b to the negative 11th power. Right, now, of course, Compass is probably going to want you to write this without using that negative 11 exponent. So the way that your answer would look here would actually be negative 12 over b to the positive 11th power, like that. Okay. If I had parentheses here around the negative 12b, and then there was a negative 11, the negative 12 would move to the denominator. But since there are no parentheses, and that negative 11 only applies as an exponent to that b. That's why the b to the 11th moves down to the denominator, and the negative 12 stays up top. That's the logic behind that method there. All right, we need to go ahead and talk about a few more of these. For example, if I have 6x to the negative 3, y to the 5th power, and then I multiplied that by negative 7x squared, y to the negative 9th power. Right. I'm going to multiply the numbers together. Positive 6 times a negative 7 is going to equal to a negative 42. And then x to the negative 3rd times x squared, I'm just going to add the exponents on the x's. So x to the negative 3, x to the positive 2, negative 3 plus 2 is going to be negative 1. Same thing right here. I've got y to the 5th times y to the negative 9th. 5 plus negative 9 is going to give me negative 4, like that. And again, course Compass will probably want you to put these answers in without using the negative exponents. So at this point, hopefully we all know that we're just going to move the x and y to the bottom, keep their exponents the same except make them positive. And that's our answer. Note here that I did not put x to the first. The 1 is an understood exponent, so that's why we're not seeing it there. If you try to put that in Course Compass, it may or may not give you an error. I would tend to think that you don't want to put it there. All right. We'll go ahead and talk about our subtraction property of these exponents. For example, if I have b to the 40th divided by b to the 37th power, I'm going to subtract in this case. I've got the same base, b, on top and bottom, different exponents. So 40 minus 37 is going to give me a positive 3, b to the positive 3rd power. Simple. All right. Let's say I have this one, for example, x to the negative 5 divided by x to the positive 16th power. And let's just assume here, just for demonstration purposes and argument's sake, that this says write without negative exponents. If we get those directions in Course Compass, we have to figure out a way to deal with that. So in this situation here on this problem, negative 5 minus 16, if I'm not too handy with dealing with the negative numbers, adding and subtracting negative numbers, what I can do is just type it into my calculator. Negative 5 minus 16, and it tells me negative 21. But if we've got these directions here, once again, highlight them in blue, then we have to remember that we need to change this back to positive exponents, so that our answer is going to be 1 over x to the 21st power, like that. Make that negative 21 a positive by moving that x into the denominator. All right. If we throw some numbers into the mix, like this, for example, I've got 32, x to the negative 4, y to the positive 3, and then I've got 4x to the negative 5, y to the positive 8, and I'm again told to simplify, and they may or may not tell me to write without using negative exponents. I want to be sure that I take care of my simple arithmetic and division, and then change my exponents back to positive at the end. So here 32 divided by 4 is going to give me 8. Negative 4 minus negative 5, if I'm having a little trouble juggling all the sign rules in my head, then what I can do is just say negative 4 minus negative 5, or however your calculator wants you to type it in, and I'll get positive 1. So it's x to the positive understood 1 power. Same thing right here with my y to the third divided by y to the 8th. Remember, we always take the top exponent and divide it, subtract the bottom exponent. So 3 minus 8 is going to give me negative 5, and I'm awfully close to having my answer here. Only problem is this negative exponent on my y. Remember, if it's just the negative exponent on the y, if there are no parentheses around anything else that goes with that negative exponent, then what we do in that situation is we keep everything else in the top, the 8x. They stay in the numerator, the top part. The y to the negative 5 moves down to the bottom, and the exponent on the y becomes positive. So that gives us our answer for that example. Just looking back at the homeworks here real quick, I know that there are several problems in there early on that cover that concept. Just looking at it right here, it appears that problems 5 through 10, yeah, just about 5 through 15, 5 through 16. Most of those problems early on, 5 through 17, 20, I'm looking at it right now, they cover exactly the types of examples that I'm detailing here on this video screencast lecture. Actually, to give you an exact, it's going to be 5 through 16 are going to cover this concept here that I'm discussing. All right, we'll talk about a couple more of these, then we'll come back and finish it all up with scientific notation and eventually factoring in sections R3 and R4. But I think we need a couple more examples here of how to deal with that power rule from the exponents. An example of when you use power rule from the exponents would be 2ab squared, and that's all in parentheses. Then outside my parentheses, I'm raising that entire part inside to the third power. Okay, so what this means is that I am raising this 2 to the third power. I'm raising a right here, that factor, to the third power. And I'm also raising the b squared to the third power. With the b squared, though, what happens now is that if we look back on that power rule, you're actually supposed to multiply these two exponents. So the 2 times the 3 would give me b to the 6th power, like that. Okay. Now a to the third and b to the 6th, they're simplified. Not so much 2 to the third power, however. With 2 to the third power, what we want to do instead is break that down. And remember, 2 to the third power really means 2 times 2 times 2. 2 times 2 would be 4, 4 times 2 would be 8. So breaking 2 to the third down into 8 will give me my final answer, 8a to the third, b to the 6th. And that's our answer for that example. And anytime you get stuck on one of these problems, just feel free to take a look at the Help Me Solve This feature on Course Compass. In years past, I've heard a lot of positive feedback on the Help Me Solve This feature. Pretty detailed step-by-step solutions to similar problems to the one that you're working. So the Course Compass has some great study and learning aids on it as well. But in the meantime, we'll go ahead and continue talking about some of these examples here. This one is going to be negative 2x to the third, but then on the outside we're going to raise the whole thing to the 5th power, like that. Okay? I don't want us to get too used to depending on our calculators, but in short, in a situation like this, very similar to the problem before, we have a